Spatial probability distribution. Assalamualaikum and hello. We would like to make a tutorial video on how to answer some questions regarding this topic. So stay tuned. Okay, here is the question. The first statement that we can see is the successful event is 0.95. And also it stated there the sample number, which is 5. So how are we going to solve this question? Okay, let's do it one by one. First and foremost, we can see that the P is 0.95 as I said earlier. So we can find Q by minus 0.95, which is P with 1. So we're gonna get 0.05. N is the sample number, which is 5. Clearly, we can see that this is a binomial distribution, so we just need to use this formula. Okay, since the question A1 stated that exactly 3 patients, we can insert 3 as the X. So just press your calculator and then you're gonna get the answer. Okay, for the next question is kind of bit tricky, but it is not impossible for us to solve this one, so I'll show you how. Okay, it stated that at least one patient, meaning that it is more or equal to 1. At least 1 means that it can be anything from 1 to 5. To make it simple, we can minus the value that is not included with 1. In this kind of situation, we are going to minus px equals to 0, which is not included with 1. Yeah, just use the same formula from the previous question for px equals to 0. And then press your calculator. Here we go, we get the answer. In question B, we are going to convert from binomial to normal because the sample number exceeds 50, which is 500. To answer this question, we need to refer to the table this time, so let's go. First and foremost, we need to find the mean, so we just need to multiply 500 with P, which is 0.95. So the mean is 475. Next, it is important for us to find the variance and standard deviation. Variance formula is NPQ, meaning that we need to multiply all. And then for the standard deviation, we just need to square root the answer that we get from the variance. So here we go. I have concluded these 3 simple steps in order to answer normal distribution. So for the first one is standardization, meaning that we need to convert from X to Z. Second one is sketching the graph. And then the last but not least is we need to refer the table from the statistic book. Easy, right? So let's proceed on how it has to be done. It says more than 480, and in order to change from binomial to normal, we need to either plus or minus 0.5, so please don't forget that. Convert x to z by using the formula z equals to x minus mean divided by the standard deviation. So here we go. And then we're gonna get pz more than 1.13. So for the next step is sketching the graph. plot 1.13 and this shaded region will be on the right side. So this is how we are going to refer the table. 1.1 over there and 0.03, and then there you go, the answer 0.1292. Easy, right? Next, my favorite question. Given the probability and they were asking for the value of n. Same with the previous formula, supposedly we will get the value of n. Since the probability given is more than 0.5, we need to convert to its find it in the normal distribution table. And then only we can minus 0.9 with 1, so we get 0.1. The nearest to 0.1 through this table is 1.28. To make it more clearer, I'll sketch the graph. The shaded region will be on the right side because x is more than. So we will shade this region. Okay, final step. Last step is we need to compare the equation of n with negative 1.28. Why negative? Because we move the negative sign from n to the next side. So you get the answer. Thanks for watching and see you guys again.